Hi everyone and welcome back. So today we're going to take a look at Unit 2.5. This is adding linear expressions and this is page 305 in the textbook. Go ahead and put today's date up at the top for me please. Alright, so I think you're going to enjoy this lesson. This is one of my favorite ones that we do. It's like when you just look at it, it looks really difficult, but it's actually super simple. Alright, so we're going to do exactly what the thing says there. We're going to add linear expressions. Okay, so if you don't know what a linear expression is, linear just means there's nothing with exponents. Okay, that's the easiest way to explain it. There's a little bit more to it than that, but that's just the easiest way. Is there won't be any exponents. Okay, everything is to the first power. All right, then the second part of the objectives will be to find perimeter by adding linear expressions. Find perimeter. Remember, perimeter just means distance around by adding linear expressions. All right, let's take a look. So it says to add and use models if needed. I'm not going to really show you too much in models. I'll show you one or two here at the beginning, and that's probably going to be it, because honestly the models take up a lot of time, and it's really don't. It's great if you use them, but if you don't, it's fine, because to me they're almost more confusing than what they're worth. But um, they they just aren't. All right, let's take a look. So the first one says to add and use models. Let me scroll down just a little bit here so we got a little bit more room. I will use models here at the beginning just so you can kind of see what we're doing here. All right, so what we have is the quantity of 3x plus 4 plus the quantity of 2x plus 1. So what we're going to do is we're just basically putting like terms together, and that's basically going to be it. So let's try that first. So remember that like terms is when they have the same letters matching, or if there's no letters at all and they're constants, then you can put those together. All right, so let me show you what this is actually asking for first. Okay, so what we're going to do is something called, these are called algebra tiles. So we're going to have an x here, and an x here. So that's 3x, okay? And then we have 4, which is going to be a positive 1, positive 1, positive 1, positive 1. All right? And those are supposed to be in little squares. Like that. Okay, that's what 3x plus 4 means. Then over here we would have 2x, and then we have a positive 1 here. Okay? So what they're wanting to do is, how many do we actually see? Well, I have 3 right here. Okay, I have 3 right here, and I have 2 right here. So we have 3 plus 2, which would be 5x. All right, now we're going to count the little units. So we have 4 here, and we have 1 here, so 4 plus 1 makes 5. Okay, what I honestly do is I just look right here. I say 3 plus and then 2 makes 5x. 4 plus 1 makes 5. All right, so let me show you with the models one more time because it's got some negatives in it. If you want to show it with the models, by all means, you go for it. It's not my thing. I was just not a model person. I kind of just looked at the numbers and understood what it was supposed to be. Okay, so let's go ahead and take a look here. All right, so this time we have negative 4x plus 2 plus, and then we have negative 2x plus 2. So this time what we're going to do is when I draw my x bars, we're just going to write negative x. Okay, so if it's negative, you just put negative. Oops, forgot the negative in there. Okay, and then we'll have 2. Let me put them down here. It's positive 2. So if it's a negative 1, then you just put a negative in front, just like we did with the x's. Okay. Now over here we have negative 2. So let's do a big plus sign here in the middle. I forgot that over here. Let's add that back. There should be a big plus sign in the middle. So plus, and we'll have a negative x here, a negative x here, and then we'll have 2 positive 1s. Okay? So again, we're adding. So how many do I have? Well, I have 1, 2, 3, 4 plus 1, 2. So that would make 6 total. So it's negative 6x. And then how many unit squares do I have? 1, 2 plus 1, 2. So that would be 4. Okay, or I just go negative 4 plus negative 2, same signs, add and keep, that's negative 6. 2 plus 2 makes 4. Okay, so if drawing the pictures out helps you, by all means, draw them out. Okay, let's go ahead and try the got it questions on 1A and B. I'll model it with models one more time, and then from there, I'll just work it out how I normally do. Okay. Okay, let's take a look here. So we have the quantity of x minus 3 plus the quantity of x minus 4. So I have 1x, and then I have 3 negatives, plus, and then I have 1x, and then I have 4 negatives. All right, so how many x's do I have? 1, 2. I have how many negatives? 1, 2, 3, 4, 5, 6, 7. So that'll be negative 7. Okay, let's try this one. So we have negative x plus 1 plus negative 3x. Okay, so I have 1, 2, 3, 4. So that's 4 x's, so negative 4x. And then we have plus 1. All right, let's try the next one. So from here on, I'm just going to work them out. If you need to draw the models, again, go for it, because it says to use them if you need to. All right, I'm not going to, just because I think it takes up a lot of time and sometimes it gets weird. All right, I'll model, I tell you what, I'll do models on 2A, just because that one's going to be a little bit different. I haven't showed you how to work with those whenever you have different signs like that. Okay, so let's just take a look. So I have a 3 and a negative 1. So if I have 3 of them, negative means to take out, right, because it means the same as minus. So if I take out 1, that means I'm going to have 2x left. Okay, and then I have 2 of them, and then plus 4, so that means I have 6 total. Okay, let me go ahead and do the got it question with you on the first one here. So if you want to use models, you can, and I'll show you how to do that. So this one's negative 2x. Okay, and then we have positive 4. Okay, then plus, and then we have 8x, so this is where it gets a little time consuming to draw this out. And then we have negative 1. 4 times. All right. So what happens is, when you have a positive and negative, what you're actually doing is you're just crossing them off. So I have 1, 2 here, 1, 2 here. Remember whenever I showed you models with integers, what you're actually doing is creating 0 pairs? It's the same thing, okay? Or think of it as the opposite way. If I take 8 and then negative 2, right, different signs subtract, so I'm actually taking them out. So how many is left? I have 6. And same thing here. So if I take these out, I'm going to have 1, 2, 3, 4, 1, 2, 3, 4. So they just cancel each other out. Okay. So when you have positives and negatives, you cancel out however many you have, and then whatever's left over is what you've got. Okay. So in that case, it's just 6x. Okay. You can put plus 0, but it doesn't matter because we don't usually write that. Okay. All right. Let's try the next one all by ourselves. And so either use the models or just work it out. Okay, so let's take a look. So I have negative 4 plus 5. So if I have negative 4 plus 5, that's different signs. I need to subtract it. So it's 5 minus 4, which is actually 1. So that's just x by itself. And then I have negative 1 plus negative 3, same signs, add and keep. So I'll add them together to get 4. Keep the sign, so it's negative 4. So it's x minus 4. circle that right there so you guys can find that later if you need to. All right, let's go ahead and turn the page. All right, so we have example 3. It says the lengths of the sides of golden rectangles are in the ratio 1 to 1.62. So the length of a golden rectangle is approximately 1.62 times greater than its width. Part A, write and simplify a linear expression for the perimeter of a golden rectangle. Okay, so for this one, and I think on the objective we're supposed to use the distributive property. Nope, doesn't say how. Okay, we're just adding and that's it. So let's kind of mark some stuff here. So we know on a rectangle that the opposite sides are congruent. So if this is 1.62x on the bottom, then that means the top here is 1.62x. If the right side is x, then that means the left side is x. Okay, so what we're actually going to do is we're going to find the perimeter. Remember, perimeter just means distance around. Okay, so perimeter means distance around. Okay, so we just need to add all these up. So I'm going to have an x, oops, that's plus, but x plus 1.62x plus, and then I'll have x plus 1.62x. Okay, so here we go. So we'll put, let's just do the easy ones first. Let's do x with x by itself. Now, yes, they all are technically like terms, but we're just going to kind of take our time here. So we're going to do 2x, and then we're going to have 1.62x and 1.62x. So let's add that up. So let's do 162 plus 162. 3.24, okay. So plus 3.24x. Now let's combine all those together. So that's going to give me 5.24x. In this case, they don't have any measurements, so this would be units. Okay. Now we're going to find the perimeter of the golden rectangle if its width is 8.3. Okay, so I always say that the width is the shorter part. Okay, so let's plug in here. So it'll be 8.3. Wait. Oh, sorry. Nope, back up. I'm going to do it a different way, but that's going to take too long. So we'll just do it these ways. So we know the whole thing is 5.24x, right? So let's just do 5.24 times 8.3. Sorry, I started to go the long way, and I realized that was going to be a lot of work. So let's not do it that way. Okay, so let's do 5.24 times 8.3. Okay, so 4.3 would be 12. Carry the 1, 3 times 2 plus 1 is 6, and then one more would be 7. And then we have 15, and then we'll have placeholder, and then we have 32, 16, and 3 would be 19, 41. I got 64. Oh, that's not right. Can't be 64. Oh, I didn't move over far enough. That's fine. Or did I mess up multiplying? Hold on. Let me see what I did here. 4 times 3 is 12. Carry the 1. 3 times 2 is 6. Plus 1 would be 7. 5 times 3 is 15. Placeholder. 8 times 4 is 32. And then we'll have 8 times 2, which is 16, 17, 18, 19, and then 40. Oh, I forgot 41. There it is, 41. There we go. Sorry. Knew something didn't look right. All right, let's try this again. So we got 2 here. We've got 9, and then we've got 14 here, so carry the 1 up there. So that makes 3, and then we've got 4. There we go. Okay, that makes more sense. Okay, now I need to back up 3 places. So 1, 2, 3, so it'll be 43.492. They don't tell us how to round, so we'll just keep it exactly like that. So this equals 43.492, and it's in centimeters. Okay. All right, go ahead and try the guided question down there by yourself, and come back to me as soon as you're ready to go. All right, let's go ahead and take a look then. So we have a rectangle has side lengths of 5x minus 1 and units and 2x plus 1 unit. So first, write and simplify an expression for the perimeter. So we would have 5x minus 1 plus, and then we'll have 2x plus 1. And we got 4 sides, so we got to do it all again. So 5x minus 1 plus, and then 2x plus 1. All right, so I've got 5, 2 makes 7, and then 7 more. So 7 and 7 would be 14x. Negative 1, positive 1 is 0. Negative 1 is negative 1, positive 1 is 0. So it's just 14x. Okay, so the perimeter equals 14x units. Now they're going to tell us that the value of x is 5.4, so let's take the perimeter, which is 14 times 5.4, and let's work that out here to the side. So it'll be 14 times 5.4, 16, carry the 1, it'll be 5, placeholder, 20, it'll be 7, and 1, so 75.6. And it's just units. Okay, there we go. All right, so that's the end of that lesson, and thanks so much for watching, and I'll see you guys next time. Don't forget to like and subscribe. Thanks, bye.